Okay, hi, BC Part 1. So in this screencast, I'm going to talk about something called properties of limits. And I should say, this is something, these properties, these are absolutely nothing that you need to memorize, okay? And so I just want to show you what these are so that when you come across a question or when you come across a phrase, properties of limits, and you ask the question, what does that mean? You have a reference point. But as the saying goes in calculus and really in anything, there's never really a need to do a whole lot of memorizing at all. There are places where you'll want to memorize just for efficiency's sake, but memorizing for the purpose of blind memorization is something that you really do not want to find yourself doing, okay? So what I'm going to do here is pull up just a question that we did in class. Maybe it was today, maybe it was yesterday, I don't remember, but I'll just do this right now. Okay, right? So here we have a limit as x approaches 7 of a quadratic expression, okay? And this is a polynomial. So you know that a polynomial is continuous everywhere. And so I know that you know that to evaluate this limit, you would just merely put in this and you would get 70 as your limiting value, okay? Now I just want to break this down and tell you that actually in the process of evaluating this limit, you were working through one of the properties of limits. And that property of limit says the following: a limit of a sum, okay? So this is a limit of a sum, 3x plus x squared. A limit of a sum equals a sum of limits. So let's say what that means. What I'm saying here is that the limit of a sum is equivalent to a sum of limits. So that's what I'm saying, okay? Now, I write this, and I also want to give you a very big cautionary tale. Do not, under any circumstances, say to yourself, oh, that means the limit can be distributed. Please do not even utter those words. Do not even use the word distribute. The reason why I say that, boys and girls, is because the distributive property refers to a very, very specific idea. And the distributive property merely says that multiplication can be distributed over addition or subtraction. It's what I'm writing here in green, okay? The reason why a limit of a sum equals a sum of limits is not the distributive property, okay? Please do not even say that. Don't think it. Please erase it from your brain. It's not the distributive property. The reason why the limit of a sum equals a sum of limits is because, we've actually been doing it right here. Because if you ask yourself, what is 3x approaching as x approaches 7? And what is x squared approaching as x approaches 7, right? If you know what each individual term of the argument is approaching, in other words, what each y value is approaching, then it makes sense that as x approaches 7 of the sum of 3x and x squared, that should equal the sum of these limits, okay? You will often see this limit, this property of limits, written in general forms as this. The limit as x approaches x naught, and x naught could be 7, x naught could be infinity, x naught could be whatever, okay? If you're taking the limit of a sum of functions, right? So all we're doing here is we're saying that there are a sum, right? F of x plus g of x, f of x is 3x, maybe g of x is plus x squared. This is equivalent to the limit as x approaches x naught of f of x added to the limit as x approaches x naught of g of x, okay? And since since addition and subtraction are the same thing, okay, I'm going to add something here, that the limit of a sum or the limit of a difference is equal to a sum or difference of limits, all right? Nothing too surprising there. I'm going to go back to this example up here, and I'm going to write this down. The limit as x approaches 7 of 3x. I'll just take that for a second, all right? The limit as x approaches 7 of 3 times x, we said this equals 3 times 7, which equals 21. Well, really, I could say that 3 is one function, namely the function y equals 3, right? A horizontal line. Remember that, Mateo? Okay, y equals x is another function. So is it true then that the limit of a product times, right there, is equal to a product of limits? Well, let's see. The limit as x approaches 7 of 3 times the limit as x approaches 7 of x. Does it make sense to you on some level intuitively, boys and girls, that if you're looking at a limit of a product, asking yourself what is the limit of one function and what's the limit of the second function? And if the question then becomes what's the limit of the product, well, let's just take the product of those limits. Well, let's see. As x approaches 7 of 3, remember this right here is just the horizontal line y equals 3 after all. As x approaches 7 of y equals 3, well, 3 just approaches 3. And as x approaches 7 of x, this is the line that looks like this, right? As x approaches 7 of the curve, on the curve y equals x, x just approaches 7. So this equals 21. And again, this property of limits just says the following, all right? If I were to write it in general terms, it just says that the limit as x approaches x naught of f of x times g of x, right? If you're looking at what a product is approaching, I hope it makes sense intuitively that you can ask yourself, what is one of the factors approaching? And then multiply it by that which the second factor, g of x, is approaching. All right, and again, there is absolutely no need for you to write down, say, these two products, two, because there's two in here, right? And these two products. I just want to make sure that on some level it's intuitive to you. All right, and then finally, I think you probably know where I'm going. You know where I'm going. I think I'll write the last one without even going through the detail here. The last one says, what do you think, boys and girls? The limit as x approaches x naught of a quotient, right, just equals a quotient of limits. The limit as x approaches x naught of f of x divided by the limit as x approaches x naught of g of x. Okay? So these properties, these four properties that are in this bright, happy, bright magenta, I don't know that you need to write them down. Maybe you could, but then make a little note to the side saying, like, these are fairly obvious. As a matter of fact, we've been using these properties all along without even knowing it, right? Okay, now the final property of limits is one that you are going to want to write down, okay? And it's not so much a property as it is a relationship between several verbs going on in a question, all right? So here I'm going to ask you this question. The limit as x approaches 9 of the natural log of x minus 9. I'm going to say the limit as x approaches 9 from the right of the natural log of x minus 9. So here's a question that I want to ask you, everyone. This verb here, the verb which is the limit as x approaches 9 from the right, when you mentally evaluate this limit, okay, what you're looking here, what you probably first ask yourself is, okay, as x approaches 9 from the right, what is x minus 9 approaching? And then after you figure out that number, you then go over and say, okay, the natural log of that number is approaching what? So in other words, my guess is if you look at this, you would say, as x approaches 9 from the right, x minus 9 is approaching what? And then you take the natural log of it. So in other words, there are two verbs here. There are two things that the expression involving x is acting through. One is the limiting behavior, and then you're saying, okay, what's the natural log of that? So in other words, if I were to ask you, this entire expression inside here is the argument of the limit, what part of that argument is affected by this, by the limiting behavior? In other words, when I take the limit as x approaches 9 from the right, what part of the argument here is this limit behavior, for lack of a better word, manipulating and changing? I hope that you would say it's this piece, the x minus 9, right? As x approaches 9 from the right, x minus 9 is changing, approaching 0, correct? And then as it approaches 0, you then ask yourself, okay, what is the natural log of something approaching 0? In other words, boys and girls, is it valid to say this? Since this limit behavior doesn't affect the fact that the natural log is being taken eventually, this limit behavior affects the argument of the log. So couldn't it be said that this expression is equivalent to asking myself this question: the natural log of the limit as x approaches 9 from the right of x minus 9. Note here, what I do, I basically reverse the order of the action. Here it was take the limit of the x minus 9, right? And then natural log of that. Now that I think about it, boys and girls, now that I've just been kind of rambling on here, I wonder if I've started talking to myself and talking in circles. And if I have, my apologies, but you know what, it's good for you, kind of like broccoli. Okay, the fact that I'm taking the limit is not changing the fact that the natural log is going to have to be taken of this expression after the limiting behavior has been accomplished. So in other words, these two expressions are equivalent because the limit behavior is affecting the argument of the log. I'm taking the log after the limit, after I determine the limiting behavior. So this is equivalent. And watch what happens here. This becomes the natural log of, as x approaches 9 from the right, x minus 9 approaches 0, right? And you know natural log of 0 approaches what number? Yes, negative infinity, comma, does not exist. Okay? Now, it doesn't mean that you can just kind of stay in this world. You can say, you know what, I'm just going to stay here. I don't really like this conversation about, switching the order. And that is fine. I will say that as you move along, however, there may be times when asking yourself, can I take this verb? Can I take the natural log after I take the limit? In this case, you can. So if you're over here, you'd say, okay, the limit as x approaches 9 from the right, so it's going to approach the natural log of 0, which is negative infinity, does not exist. All right? But there would be times when it's kind of to your advantage just in terms of efficiency, in terms of algebraic ease, to ask yourself if perhaps I can reverse the order of the two verbs going on here. Here's another one. How about this one? The limit as, let's see, how about this one? As x approaches 16 of the square root of, I don't know, what should we do? Okay, x minus 12, right? Boys and girls, what are the two verbs that are acting upon x minus 12? Look what I'm circling. What two things are happening to the x minus 12? There are two things. One of them is the limit x is approaching 16, right? So in terms of x minus 12, there are two things going on. One thing going on is x is approaching 16. But what else is going on? You're also taking the square root of it. Now, I know that many of us would look at this question and say, okay, this is going to equal the square root of 4, which just equals 2. But look what happened. Even in that quick move, you determined this number 4 by saying x approaches 16, so 16 minus 12 is 4. And then you took the square root of 4. In other words, true or false, this is equivalent to the square root of the limit as x approaches 16 of x minus 12. Okay? True or false, is that a valid thing to do? True, that is equivalent. Okay? It is absolutely valid to do that. All right, I think I've belabored this point quite enough. And this conversation below the black squiggly line we'll come back to several times. Okay, this is not the last time you're seeing that. But I just lost my train of thought. Good heavens. Oh well, I'd like you to also do these problems, please. Page 97 in your text, number 5. And that's it. But I'm going to be very honest. 5 has parts A through H. Okay? So page 97, number 5, parts A through H. Good night.